Hi, Eric.
Hello, Adam. How's it going? Hi. Nice to see you.
Wait, I thought you were going to break into a sea shanty. I was totally ready for it.
Oh, no, I was doing hello, Dolly. Well, hello, Adam in this case. I was considering doing hello, blockchain, but then I didn't know where I was going to take it, so I veered at the last minute. I zigged. Oh, how's your week? Happy Thursday.
It was good. It was good. Oh man, it went by fast. I was actually wrote a lot of code this week. I did my weekly snippets this morning, and I was like, oh man, I've been busy. How about you? How was your week?
My week also blew by, but it was a lot of meetings. We're doing a whole, dog and pony show, talking to lots of people at the moment. So I did a lot of that right now. So.
Well, I did. I reorganized my schedule. I moved all my meetings to Tuesdays and Thursdays, and tried to keep Monday, Wednesday, and Friday clear for actually like writing some code. And it turns out that having big blocks of time to write code is way more efficient than little tiny blocks.
Yeah. No, you just can't. At least I need like boot time to get into flow. So I learned, I don't know if I said this on the podcast, but I learned, it was a New York Times piece that was talking about languishing. This was like a week ago, and I really identified with that piece. And it was talking about how the cure for languishing is flow.
What is languishing? Can we back up?
Well, before
we get the cure, what's the disease?
It was talking about like, what is it that you're feeling in this, this last year of life sort of being on pause, but not really on pause, and then all the stress and stuff. And they were giving it a word, which saying is helpful. Anyways, I'm now going to fail to remember the article as well because I read it now a week and a half ago or something like that. But I really, it struck a chord with me. But anyways, it was talking about how the answer to this is flow. And for me, that's, go write some code. It also talked about watching TV or just like things to like get your brain in this like engaged state.
This week I was totally engaged. I was like writing code while I was trying to fall asleep in my head, which is never a good thing because like the code you write while you're falling asleep is like just disaster code. Like do not type that code in the computer; it will melt the computer.
So, so tonight, speaking of melting things, we were talking about it's all the rage all over the internet, all over the Twitter, this blockchain thing, if I may sound old and uninformed.
Kids these days with their blockchain. In my day, our chain didn't have blocks.
No. Yeah. So we were going to talk about that and maybe write some code.
Yeah. Okay. So I started looking into this a little bit, and the thing that I discovered, which I'm sure everyone else already knows, but was news to me, is that at least on some of the blockchains, they have a little virtual machine inside of them, and you can write code that then compiles and runs as the blockchain develops. And I thought that was cool. I know how to write code. Maybe we could write a little bit of code and try to run it in a test blockchain or something. And like, whenever I discover new things like this, my inclination is always to try to write like the hello world of that thing to try to see what it's like and taste test it. Yeah.
And so we were going to do a little bit of that tonight. We were going to taste test. The VM you were talking about is this Ethereum, the Ethereum blockchain. And my limited understanding is that unlike some of the other blockchains that we talk about, which are just about trading gold, digital gold around.
Coins of some sort.
Yeah, this is about, this has the ability to run script. And so there's other things that have been built on it. And we were talking about building hello world in that world. Yeah.
Yeah. So I think the basic setup is you write some source code, you compile it to some bytecode, and then you somehow put that bytecode on the blockchain, and then it gets an address. Then you can send it messages and pay it money, and then it can pay you money or
something. Oh, really?
Like huh. Oh, yeah. The program becomes this like wallet that you can then deposit money in, and then the money is then controlled by the program.
Oh.
And not by a human being anymore. And so you can set up sort of like, what are the rules of the road? Like who can put in money, who can take money out? How does it decide? Like,
so basic primitive of the so Ethereum, since that's what we're talking about, is money a basic primitive of Ethereum, or is gold itself built on top of the VM?
No, it's a basic primitive. In fact, when the VM executes, every instruction that it runs costs a little bit of money, and so you have to feed it enough money to actually get the VM to run.
That's this gas thing they talk about.
That's the gas, yeah. And it has a different unit. I think it's called Way or something, but it's just Ethereum, but like 1/1,000,000th of an Ethereum or something.
Sure.
It's like because each instruction of the VM is worth only a tiny fraction of a.
Yeah. And when you run these things, are lots of people running this code? I presume, because it's a distributed system, right? So when you put something into the blockchain, your then code gets run in a VM 1,000 times, 1,000,000 times across the world. What?
Yeah, I don't know what the number is, but some absurd number of times. And then basically to make a new block in the chain, they have to run all of the programs that are contained in that block, and then they get the answers and they store those values.
I see. So if you want to like add a block to the chain, do you have to run all of the blocks up until then to get to there, or can you like inherit state and then run a block on top of that?
I think you download a summary of the current state of the chain where you don't have to like recompute all programs at the beginning of time. They give you some summary statement, or I don't know how, like, I imagine it's quite, everything I look into this area seems to be quite sophisticated. So I imagine that it's quite sophisticated, but.
It's just amazing. As we were looking a little bit through off screen, and I was installing the Visual Studio Code extension, and it had 300, I mean, first of all, there were like 30 of them, but then the top one had 300,000 installs for the contract language of Ethereum. So like, we're already way in the weeds of a specific, although it appears to be increasingly the sort of the dominant of these blockchains, at least in maybe not for monetary value, but for like utility and wider things, Ethereum.
And like innovation, like as far as I can tell, a lot of the innovation is going into Ethereum.
It seems that way. I listened to a talk recently, and they were all about Ethereum, even though that wasn't their specific thing. It's just like it was the conduit to their thing. So as you can tell, I don't know anything about this. This is not a UI framework. I have not worked on it for 20 years. But it'll be fun to stumble through it tonight. Shall we move on towards the code machine? I mean, there's a lot of stumbling yet to do, but
yeah, for sure. So when you want to put it on screen, I'll give you some context.
Oh, that's right. I have to press the buttons.
So this is some sort of browser-based IDE that I got to. So the programming language that you use to program at least Ethereum is called Solidity. I'm not sure I'm pronouncing that correctly. And then I found a thing called Solidity by example, which is my favorite learning mode, is by example. So this website spoke to me, and then it had a whole page of like, how can you install this thing so you can run it? And their first option was like, okay, you can just totally run it in the browser in this IDE, and that's the simple way. I was like, cool, I'm in for that. Mm-hmm. Then I read further down the page, and it was like, well, you can get it from NPM, you can get like a Docker image and run an entire container containing this thing. Anyway, it clearly goes to 11, but this is the dumbed down, like kick the tires version of it.
And we did try some of that. The 20 minutes before the show, like I installed some of the NPM stuff and we tried to get it set up. We didn't quite get there.
Yeah, we couldn't quite figure out how to run, but I figured out how to run in this thing. So I can give you a brief tour. So this is, you just load it up for the first time after you dismiss the thing that says you don't want to be tracked. Then this is what it looks like. And so in here, they give you 3 example contracts to play with.
Okay.
There's the README. The other neat thing is this whole web-based IDE also has a plugin system. And so one of the plugins is the tutorial. And so it has like the tutorial built into itself. So that was kind of cool.
I wonder what IDE this is. I presume this is not like a specific IDE specific for, did I say it right? Solidity? Solidity, yeah.
I don't know. Like it's clearly very plugin based. So maybe it's some sort of base thing that this community has built a lot of useful plugins for.
Yeah, who knows? Anyways, you were giving us a code tour here.
Yeah, so this is one of the example contracts.
Underbar semicolon? Maybe go ahead.
Underbar semicolon.
Maybe that means not return.
Where are you looking? Oh, here?
Yeah.
I don't know.
I mean, I don't know. Sometimes we use underbar to mean like
ignore.
Anonymous variable. What?
Yeah, I think this means like don't do anything.
Yeah, like a no-op.
Like I don't want to actually run any code. I just want to basically add this constraint.
Okay.
So contract. So this is like a class sort of thing. So contract is this is all this stuff works together as some code and data. So this is its private data, which is an address on the blockchain. So addresses are things that can send and receive messages, and they can also sign messages so that you know that it came and is going to the right place. These are events, which apparently you can emit and are easy to monitor interactively, for whatever that means. The constructor is run when the contract is first added to the blockchain. So when it's added to the blockchain, it gets an address that then you can use to communicate with the contract, and the constructor is run. So the message is the message that was used to instantiate the contract, and the sender is the address of the person who sent the message. So in that case, it's going to be us because we're going to install this contract. And so what this does is, by default, or at the beginning of time, the owner of this contract is whoever sent it. Mm-hmm. And then it emits this event, and then you can change the owner. So anybody in the whole universe can send this message because it's public. So you just say, I want this person to be the new owner, and this contract's like, cool. So this is not a very secure contract. Anybody can become the owner at any time out there. And then it's got a way of seeing who the owner is. So the view means this is not actually this business function can't have any side effects. It's something you can just run locally. If you have a copy of the blockchain, you can just run this yourself without sending any messages to anybody. So it just tells you who the owner is. So the next thing they told me to do in the tutorial was to compile it. So I can select which compiler I want.
Why not?
That one seems fine. I don't know. I can include the nightly builds if I want to live on the edge. Anyways, I click compile, and it's like, boom, totally compiled. It gives me a bunch of like options for publishing out of here, which I don't care about.
One click to publish on IPFS.
Well, of course, like obviously, don't you want to publish on IPFS? IPFS is, as far as I can tell, is a distributed content network where things are addressed by their like hash or something. Okay, and then over here is our VM. So I'm going to run it in the JavaScript VM. So this is just running entirely in my browser. This is not running on the real blockchain. It's like a simulation of what's happening so you can test out your code. I think this is probably like an absurd amount of gas. Gas is what gives your program budget to run. So let's just deploy it. Boom. So now here we can see in our VM state, we have one deployed contract on our blockchain. And so these are the different methods that came from the contract. So you can call it the get owner method that says, well, this is the owner, the person who created the contract. And then you can change the owner. So I don't know what other entities we have in our universe. We can make it own itself. Should we try to make it own itself? Paste. Change owner. So now I think if I call get owner, it'll be D9. Yeah, D91 instead of whatever it was before.
I wonder if you just send it foo. Does it like say that's not a valid address?
Well, good question. Food. Oh, foo.
Either way, whatever. So.
Get owner. Did not seem to affect the owner.
Okay.
I'm not sure if there was. Fact. All transactions. There are only 2 transactions recorded, so I think it did not. It was not happy.
Validator was like, oh, that's not an address. I'm not sending it.
There's a console down here, which maybe will tell us more about what happened.
Error, argument, invalid address. Right there.
Yeah. Okay. It was like, that ain't a thing.
It was.
We can deploy the contract again.
I was listening to someone talk recently about Web3, and it's interesting. This talks about Web3 as well in this UI.
Yeah, my understanding is Web3 is like a giant ball of JavaScript that you run in Node.js that allows you to hit a bunch of web services and run all this stuff.
Oh, I
So
was
like,
hearing it referred to as like this is Web 3.0, which is like different from the current web revolution. But I don't know.
yeah, I think that's a branding thing, but there's literally a big ball of JavaScript called Web3 that you use to write JavaScript that can interact with these things. This, I think, is mostly hiding that from us.
Mm-hmm.
Although maybe if we go into scripts, yeah, so this contract.
So I'm starting to understand why it has its own language. Like at first that wasn't apparent to me, but it's just doing things that are different. Like the fact you would want an address to be a primitive data structure in your language in order to make it simple, if nothing else, right? You don't need everyone needs to load in the giant address class, right? No, it's just like this whole thing deals with addresses. It's going to be a primitive.
Yeah, it's like super excited to think about like 256-bit numbers, because that's the like natural number type that it's dealing with. I think that's the size of an address. Also, storage and memory are incredibly constrained and important because you have to pay for each thing. So the VM apparently is built as a stack machine that then also has volatile memory and then has non-volatile memory. So non-volatile memory or storage actually gets stored in the blockchain and recorded forever. Volatile memory is just in case your stack isn't big enough to process the data you're working with, you can spill it over into memory. And then you can't access memory directly. You have to basically load from memory onto the stack and then work with it on the stack in the stack machine.
Fascinating.
But like, as to why it has a language, so I don't know if this has an example, but like a kind of function that you can have is a payable function, which means when you call this function, it's expecting to be given money. And then it can take that money and do something with it. And it's very important to know which of your functions are payable, because if you send money to a function that isn't expecting it, it may just not put the money anywhere, and then the money disappears forever.
What? You can send money to null? That seems like
it gets delivered to the address, but if the contract has no knowledge about it, it will never have any rules for sending the money to anybody else. And so the money will just accumulate at the address of this contract, and then there's no way to get it out. Like there's no.
It makes you
can't
wonder,
like go into the debugger and like extract its money. Like
it makes you wonder how much money is just like sitting at dev null, effectively, right? Leaked. Maybe it's the way to think about it.
Yeah. So instead of leaking memory, like there's this old joke about like as computing becomes more advanced, you leak more and more important things. So like at the beginning, you would leak memory. Like in the cloud computing world, you would leak virtual machines. You start leaking computers. And then like at some point you start leaking data centers if you're like operating at large enough scale. And in this world, you leak money and the money just disappears.
Huh. So fascinating. And so these requires are basically asserts. They're just always run asserts. I pieced that together from the previous example.
Yeah. So this says like the only person.
The transaction.
Correct. Yeah, and importantly, if your transaction gets reverted because of a require, the money gets refunded to the sender if it's a payable. So the documentation is all very big on if you have a payable method, like make sure you put all your asserts up front, and like try to error, but in that way, so that the money doesn't disappear into the universe. Also, apparently, there's also an instruction called self-destruct that your contract can have. And then once your contract self-destructs, like it no longer listens to any of its methods. But if it has a payable method, people can keep sending it money. And apparently just the money will just sit there and no one can get it out.
Oh, man.
This is another very, very interesting type of data that these things can have. So apparently it's very common to want to store state on a per address basis. So this is like a dictionary. It takes every address in the entire blockchain as a key and then populates it with whatever kind of structure you want. And then it's set up so that if you like query an address that you've never seen before, it's you get back 0 or something. And this is somehow efficient.
This is fascinating. It's gonna. I need to let this soak in my brain for a bit. Huh. So I don't even know if we're ready for this, but like, what would hello blockchain look like?
Oh, I think we should totally try it. Like, what's the worst that could happen? So we to steal. They're also really big on license identifiers. I don't fully know why, but they really want you to have a license identifier.
I guess because everything is public, so you have to understand who's allowed to read your code or like what they're.
I guess. I don't know. Let's make a contract. What do you want hello to do? We can't really print. I don't think print is a thing. But we can make a counter.
You can't really send messages back and forth.
What if we did like a counter, right? So like we want, how do we make a function? Function.
I mean, so what do you do in the blockchain? You move money around. You also move addresses around.
I'm sort of stealing the like beginning Flutter program, right? It's like the beginning Flutter program also was not like hello world. It was like a counter.
Sure.
I have no idea if this is going to work, but public.
Okay. It doesn't like your return, I think.
Found modifier. So how did this do it? It
made a whole
address. Oh, it put it on the other side. Maybe the visibility specifier comes after the type.
So is this data?
This is unhappy. Oh, this thing needs to return something. Int. How do you make a return type? Oh, parentheses, of course. It's a super wacky syntax.
You need to remove the arrow.
Oh, I got the arrow.
It just looks like
I've been running expected, but got thing. All right, we totally did that wrong.
All right, let's go look at the
external view. Oh, returns. Slow down. What's that?
What's the external? You're
I think external means. I think so. Public, I think, means it can be called from outside the contract. I think external means it doesn't even run on the blockchain. Like it runs locally on your computer. You don't actually need to send a message to make it happen.
So what is the lifetime of counter? Is that like recorded in the blockchain?
Yeah, forever and for all time. And also public in the universe. If you get to pay money to put it in the blockchain, but once it's there forever. In our little like pretend VM, we don't need to pay any money.
And so then every time someone paid money, gas. I mean, gas is something you buy with money, and every time someone paid gas to send, or when you sending messages to contracts, does that cost gas?
Yes.
So like if you send a message to a contract, I see you put a gas limit because you don't have any, you don't know how hard it will be to run the method that you call.
Mm-hmm. Yeah. So you put like an upper bound, like
yeah, it runs out of gas. $10 to run their code.
Yeah. If it runs out of gas, it throws an out of gas exception, which then reverts everything and sends you back the money.
What? So sorry, I started. How do you update code, or can you?
You can't.
So what do you do when you have bugs?
Don't have bugs. I don't know. What I think, like, you can write into a contract. Maybe we'll try to do that with this contract. So the only real reason you would care about a contract is because it has money in its wallet. So you can write into your contract, hey, if you get this message from some special person, transfer all of your money to the address that they specify. So that would be a way of then you could load up the new code at the new address, tell the old contract, give all your money to the new contract, and tell everyone to forget about this old thing and do your new thing. But so we can try that.
Well, but if you do that, I'm sure someone's thought of this. You talked about self-destructing, right? And self-destructing turns off all of your methods except your payable methods?
We can research what self-destruct is.
Yeah, we should do it. But not this second. Let's see if our thing runs. If your thing runs here, right?
So I think in the artifacts directory, I think it auto-compiled.
Okay. It's got a big compile button.
Yeah. Should we try to deploy it?
Yeah.
Deploy. Boom. Okay, so now we have the owner contract and the hello contract. Get count. Get count is 1. See, I just said int, right? And then int is like, oh, you want 256 bits, right? Because that's how their world rolls.
Okay.
It's the future.
What's
so we try increment? Increment. Get count. It's now 2. 1, 2, 3. Should be 5. 5.
So how much gas did the increment cost us? Like, does it tell us?
Sure. Let's find out. So let's see. This is increment.
So it's 0 whey. And is whey a fraction of gas? Oh, no, there it is. Execution cost 6,200 gas. Wow, the transaction cost was way higher.
Okay. This is the name of the transaction. It came from us. We sent it to hello increment.
Yeah.
We gave it this much gas.
Well, max gas, yeah.
This is our max gas. Like just issuing the transaction at all, I guess, cost that much. And then it costs this much to run our bytecode. I don't know what this is. Inputs, output, logs.
Crazy. What is whey?
So I think that I think gas is a property of the like a certain instruction, like an add instruction, will cost a certain amount of gas. But then there's the question of what is the price of gas? So I think whey is then the amount of Ethereum that you pay to purchase that much gas.
Mm-hmm.
And so depending on how congested the network is, so like right now, because these NFTs are super the rage right now, everyone wants to run code on the blockchain, and so gas prices are very high, meaning there's a lot of people wanting to run add instructions, and so you have to bid a lot to get the people who are actually adding blocks to the chain to run your add instruction instead of somebody else's add instruction.
I see. So gas is variable in price.
Yeah, gas is just this is how much, I don't know, CPU memory cost it took to run my program.
Yeah.
And this is how much I paid for it. Where I think whey is just some fraction of an Ethereum unit, some fraction of money.
I see. So there are fixed gas prices in this simulator, presumably.
Yeah, I think in the simulator they set the price of things to cheap.
Fascinating.
And I think you can actually. I think if you set a high price, like suppose you have a transaction you really want to have happen, I think you can say the gas for this transaction I'm willing to pay a ton for, and then that'll make the people adding blocks to the chain really excited about adding your particular transaction to the next block, because you're paying them a lot for the ability to
go ahead and line kind of thing.
Yeah, and so you can trade off like how the latency you want for your transaction against how much you're willing to pay for it.
Huh. Yeah.
The whole thing about like integrating money with computing, I think, is super interesting. Like, It's for a while many years ago, I was interested in integrating law with computing and sort of in a way where the computer could like understand what a law was and like understand whether someone was following the rules or not. But I think doing it with money is more interesting because like you have a lot of these interesting trade-offs that you can make. Like normally in computing, you have trade-offs between like throughput and latency, but now you have a throughput latency like budget. Like you can work with it all.
Well, in this system, also there's some amount of law, not like.
Well, they call them contracts, right? They're clearly like
they're
aiming for that
direction.
legalistic.
Yeah, it's interesting to me that they chose the word gas. I mean, it makes sense as an analogy, but like it's sort of I wonder if it's a dying analogy. But go ahead, you were saying.
Oh, I think the idea with contract is like, suppose you and I both put money into this thing, then it governs the way in which our joint account is working.
Is there like a more sophisticated contract? Go ahead, sorry.
Yeah, like I would have called it account, but whatever.
Is there a more sophisticated contract we could look at? Because I think we conquered hello here, right? I don't feel like I'm ready to write a fancier contract. Just need to read one.
So this is a voting process with delegation. Okay. So voter. So I think I saw this one or some version of this in the tutorial. So I can try to explain how I understand this. So this has delegation. So it says, I don't want to vote on this proposal. Eric, you can vote for me. So like if I delegate to you, then your voter struct will have a weight 2 because you've accumulated 2 votes. And then this records whether you voted or not. So you can't vote twice. If I delegate to you, I put your address here, meaning I've signed away my thing. Now you can sign. And then this is which proposal I want to vote for. These are just the proposals. They have names and then number of votes they got. That makes sense. There's somebody who's the chairperson. And then for every address in the entire blockchain, I'm going to keep track of this information about them here.
In a sparse map.
And then here, yeah, this is a sparse mapping of some sort. Although it seems to be fairly scalable because there are other examples where you can create your own tokens to exchange. And the way they built those is they had a mapping from address to like how many tokens that address had. And I don't know whether that was just for the example or whether this data structure is actually scalable to potentially include a count for a sizable fraction of the number of addresses. I don't fully.
I think it's also interesting to think about in this like different programming paradigm. Like you have different like performance characteristics. You have different like best practices, and I have no intuition for any of this. But
I don't know either. It's like it's a whole new space to explore, which is why I get excited about it. Okay, so this is you can construct the thing. I guess you give it a bunch of proposals. So this comes in memory. My guess is because this is too big to fit in the stack machine. The person who created the contract is the chairperson. The chairperson gets to vote. It gets 1 weight. And then it basically pushes all the proposals into this vector, which then basically moves it from memory to like persistent storage.
Okay.
So then I guess the chairperson can give somebody the right to vote. So they can say this address is an eligible voter. So they have to have not voted before, and only the chairperson can do this. And they cannot have been delegated anything yet. And then they get.
But it's not per proposal.
No, so this is like a.
This is a vote instance. Oh, it's a ballot. Yeah.
It's a ballot, right? It's more than a ballot. It's an election, right?
Yeah.
This is like each entry in this map is really a ballot.
Yes, but it's an initiative election, right? there's a specific set of proposals. I don't know. We have these initiative elections in California, right, where the prop whatever, and those props
a
are
person,
being
right?
missed, and then it's being run just for that little subset. You were saying?
It could be like a person. Like, let's say these are the three people who are running for dog catcher. Like, the proposals could be, person X should be the dog catcher.
Oh,
Person Y should be
proposal
the dog
is
catcher.
or.
Yeah. One of the proposals is going to come out as like that's the one that's been agreed. But I find it's very interesting to think about like what are the bugs in the program. Like, imagine you had not written this require statement, right? So then this would allow the chairperson to basically suppose like a lot of people had delegated all of their votes to Eric. Then the chairperson could come in and say, "Oh no, you only get one vote after all." Or like what if you like this is an obvious one, like if you forget this check, then anybody can give anybody the right to vote.
Yeah.
I think this language, like if I were trying to think about this language seems very optimized for dealing with the performance characteristics of this environment, but doesn't seem optimized for dealing with the security characteristics of the environment. Because like this to me is like such an important aspect of what's going on from a security point of view that if I were designing a language to work with these things, I would make that a first-class concept in the language, and like I would have a compile error if you didn't like explicitly list like who is the set of people, and I have to write something here like everyone if I really wanted everyone to be able to call this. Or like another piece of it is there's a lot of in these things there's a lot of implicit state machine, and there's a lot of opportunity because these messages it's a distributed system, right? So the messages can arrive in whatever order, adversarial order the attacker wants to send them in. And so like I almost wonder if like some sort of more state machine oriented description would be a better way of reducing errors, because like you might want to just like maybe you could only give the right to vote in a certain state of the machine, and then once you advance to the election you can no longer change the role of the set of eligible voters. But that's not set here. It only says that the person can't already have voted. But in like a real election, like for dog catcher, they have a cutoff point. They say if you're not registered to vote by Friday, then the election is on Tuesday. You can't become registered to vote on Monday. So sorry, I spent a ton of time in the security world, and so like whenever I see things like this, my like security brain gets really activated to be like.
Yeah, I look at this environment and I share your concern that I just don't know how you write a secure thing in this environment.
But what I think is neat about it is this text-based thing is only the front end, and the thing that actually like is committed to is the bytecode that runs in this virtual machine. And so I think it's entirely possible for someone to come by and say, okay, really the value trade-off that this particular language has made doesn't match the stakes of that are here. Here's another front-end language that emphasizes different aspects of the problem that could then be useful for writing, let's say, contracts that deal with very large amounts of money or otherwise have very high stakes, or for which correctness was more important than efficiency. Or maybe you could get it all.
A million interesting dev tools you could write on top of this, right? That spit out the performance characteristics, the expected cost characteristics, but also like automatically fuzzed or showed you like that coverage was like a primitive. I don't know that coverage is actually the goal, but like because again, you're
well, they seem really into tests. Like here are the tests for the ballot, right? Like
if you tell you can never update this code, this is worse than shipping it to the moon, right?
Yeah, like when they ship code to Mars, like they can actually update the code on Mars, and they do this, and they do all these like crazy hacks because like, oh, this unit on our circuit board got hit by a cosmic ray and it's unreliable, therefore we'll change all of our code to like not use that functional unit.
And so that's probably in the language somewhere. We just need to like maybe the shutdown does that kind of thing, or you shut down with an address and like you're just delegating to like a different version. Like I could totally imagine a thing like that, right? Where it shuts down an address and be like, oh, this new address is actually where the new version is.
But it's tricky, right? Like let's say like you and I are each going to put a large amount of money into this contract, and we are willing to do that because we agree and understand about the rules by which the money will be dispersed to other people. Right? If you allow an update mechanism, that means somebody can change the rules for how that money is allowed to flow. And so somehow the like trust relationships of the people involved need to also be implicated in the update mechanism.
Yeah, I can see why people think this space is interesting. All sorts of fascinating.
It's totally fascinating. Anyway, should we keep going through this?
Yeah.
Okay, so this is the delegate operation. So anybody can call this. They say who they want to delegate to. So if I want to delegate to Eric, I put Eric's address in here. So they look up the sender. So that's me in this thing. And they get, so this basically says this variable is still in storage. So this thing here is in permanent storage. And this is saying, don't try to like load it into memory or anything. I just want a reference to that record that's still in storage. I'm not working with it yet. So then you can't delegate if you've already voted, and you can't delegate to yourself. So like this is another very common, like, what if this require wasn't here? Like cycles and stuff. And then it has this interesting loop where it says, so who am I delegating to? If they, so 0 is a special address, I guess, that no one is allowed to occupy. So if they've delegated, then keep chasing the delegation chain to try to get to the end. And then there's also some sort of like loop detection here. In the tutorial, they were explaining that like loops in your contract are very dangerous because you don't know how much gas is going to be required to run the loop because, you know, the halting problem or something. Right? So then you count as voted, delegating counts as voted. Your thing gets recorded to the ultimate thing that you chase down to. You load up the ultimate thing you're chasing down to. If they've already voted, then your weight gets sent directly to the thing they voted for. Otherwise, you increase their weight. But this is super subtle code. Like, I have no idea if this code is correct or like if there's interesting checks like this or like. And
this is the example.
Like, I might have thought of. I mean, this is example contract number 3. Like there.
No, but what I'm getting to is that we're talking about the subtle code in the third example, right? I'm sure there are much
this
more.
This isn't like a real production piece of code. Like we can try to find one of those, I guess, and try to look through it and be like amazed by it, but
or horrified, but yeah,
or horrified. And I think there's 2 more functions here. So if you want to vote, you say which proposal you want to vote for. They look up your record. You have to have the ability to vote. You have to have not voted. They say, okay, you voted for the proposal, and we give your weight to there. So this I think is not that subtle. Like this to me feels like if I were approaching this problem for the first time, like maybe I could have written something like this.
I'm just thinking, my brain is going off in all sorts of directions. Isn't this space somewhat security adjacent?
I think so, but I haven't seen a ton of, like, I've seen like articles about people have written contracts with bugs and they lost X amount of money and they were sad, but I haven't seen like the security community put the kind of focus and attention to thinking about this problem as they have, for example, put to the DNS system or put to the Java VM or put to browsers or something.
But
maybe that's happening. I'm just not aware of it.
Yeah. Well, just if it's security adjacent, and as I said, there's 300,000 installs of this for Visual Studio Code alone for the syntax highlighter, right? You would think that people are like, I think of you less than I would like. I have previously occupied a security adjacent space. Right. And so like people are way more into security than me, certainly, and I suspect more than you as well, would have thought of all the things that we've thought of in the last 15 minutes. But
undoubtedly. Like there's also a ton of security focus at the layer underneath this of like the underlying machinery for sending and receiving the money. Like that's something that I've seen a lot of security attention paid to, but I haven't seen as much what we would call application security. Like what it, as opposed to like the analogy from the sort of classical internet is there's like transport security. Like how did my HTTPS session with the bank go so that the bank knows that it was me who is talking to them? That's sort of the equivalent is like the blockchain. Like, can somebody like insert a malicious block, or can they trick other people or things like that? But then there's also the application security, which is like, okay, what is this transport or mechanism used for? How do the people who are running all the applications on top, how do they write things that are sensible and like do what they want? And I haven't seen a ton of that.
I also wonder, and I'm sure this is knowable, like what are the most popular contracts on the Ethereum blockchain? I'm sure like it must be knowable. And it'd be fascinating to like look at them.
I mean, okay. What is the most popular contract?
I'm sure there's a list somewhere.
Okay.
Non-ERC20. What's an ERC20?
Right. Okay. So now we're getting a little bit into the ERC20. For tokens. So let me try to find the actual ERC20. The ERC20 is a spec. Here it is. So ERC is like their equivalent to the RFCs. So this is a spec for a protocol that specifies here are the methods and here are the events. And then I don't know whether they give you sample implementations or not, but with this ERC20 is a fungible token. So this is a fungible token. So this is a thing, like you can build your own coin on top of Ethereum. And then you can, if you abide by this interface, then people can build tools that generically know how to interact with all coins, and you can interact with your coin. And then you can do whatever you want with your coin. You can make yourself familiar to them and give them out at parties, and then people can redeem them for, I don't know, slinkies or something, whatever you want. But this specifies the interface. So that's that. And then the NFTs, the thing that's currently really hot, has its own ERC. This one. I guess it came much later. It has a 3-digit number instead of a 2-digit number. So like this is the API that your NFT needs to have. And I'll give you an example in Python.
This is the API and not, I won't say the implementation. Because that's knowable, right?
Yes.
All this code is public.
Yes. So here's a CryptoKitties. I think is one of the first. Oh boy. CryptoKitties is
careful where we're going here on the internet here.
No, CryptoKitties I think is okay as I understand it. CryptoKitties was one of the very first NFTs. You can look at its Solidity. Okay, so here's the CryptoKitties contract. So it was written in an older version of Ethereum than the one of Solidity that we've been working in.
And is the ABI stable?
The bytecode is stable. The source code is not. So I was looked, for example, at the change description for the latest release, and they're like, here are the things that we did that are going to cause your code not to compile, and here are the semantics we changed underneath you. Even though your code compiles just fine, we've changed what it means. So, for example, one thing they did in the latest release is they said, well, integer overflow now generates an exception that will unwind your contract and revert it, because people were having integer overflows and that was messing up their math, and we decided to just like forget that. But that only affects the source code. Like once you've compiled it to the bytecode, then the bytecode is ABI stable. And the bytecode is the thing that people have actually encoded in the blockchain.
Okay, so this is old Ethereum, but theoretically readable contract.
Well, we can find out. I haven't gone back in time to see. So this is their API that they have to meet.
Whoa. Can you go back up? Transfer ownership. Okay. We still have this. We have this underbar semicolon again. Like, are we missing a require here in the transfer ownership?
Well, it's here, right?
Oh, only an owner. Okay.
Yeah. So this is a modifier. So you can.
Whoa.
But the mod. Oh, now I remember this. Okay. This is like really sketchy PL design. So my understanding of this is basically this thing takes this syntax and like jams it in here.
Oh, it's a macro basically.
A macro. But I've been learning about like Rust macros, and Rust macros are like done correctly. So Rust macros, when you write them, you're like in the compiler. The compiler gives you all of its beautiful data structures, and you can work with them. This like strikes me as very syntactic, which reminds me of C macros, which terrifies the living heck out of me.
Oh my, yeah, see, oh.
So look at this. So look at this. This is interesting, right? So transfer ownership to this new owner. So the owner can't be the address 0. So remember, in those other contracts, we didn't have a lot of checks like these, right? Like you could totally give address 0 the right to vote, or you could delegate to address 0, or who knows, right? Anyway, so then they become the new owner. This is the contract definition. Gene science interface. Okay, mixed genes. Yeah, the CryptoKitties are like pretty elaborate NFTs. Okay. Access control. Oh, wait, this is pretty long. Just for reference, this is 2,000 lines of code long.
That's okay.
Let's go a little fast here.
Others are.
Well, the CEO, the CFO, and the COO. Okay. Controls the access control for CryptoKitties. The CEO can do all kinds of stuff. The CFO can take the money away. The CEO can release Gen 0 kitties to auctions and can mint promo cats. Like you see where this goes, right? It just goes like totally like
this is great.
Like the like range of expression here is just enormous. Anyway, so there they are. These are the like things. Paused.
Okay, and so that's like written in the chain, but it can be changed. Yeah, modifier only CEO. Okay. Yeah.
Okay. Only C-level. You have to be an executive. So only the CEO can change the CEO, and address 0 cannot be the CEO. So you can never disclaim like somebody has to be the CEO. Okay. The CFO. Only the CEO can appoint the CFO and the COO. When not paused. When paused. Okay. You can pause it. Any executive can pause when it's not paused. Pause becomes true. Unpause. All right, there you go.
The decorator thing is actually kind of neat. It may be sketchy, but like I like the programming style.
You better hope that it does what you remember it does. It does, otherwise.
Oh yeah.
Okay, here we go. Kitty base. So, by the way, I think CryptoKitties is more elaborate than your average NFT. I think your average NFT is really just like, oh, this person owns it, that person owns it, whatever.
Sure.
CryptoKitties has this ability to like breed the cats, which we're going to find, I'm sure. So, oh, there's a birth. This is the you can transfer. Okay, here's your kitty. It has some genes. Cooldown, matron, sire, blah, blah, blah. Here are the cooldowns.
It's a cooldown.
I think they don't want the kitties to like breed too quickly. So like time has to pass in the real world. One of the things you get with a message is the timestamp at which the message happened. So you can say like, it has to be 16 hours since the last message to like.
I love that time is a primitive in this language.
Oh yeah, time is a real thing. So like there was some other contract I was looking at that was like, okay, there's an escrow thing. So you're going to put your money here and like 2 weeks later you can get it out unless somebody else has complained. And so like it just like uses time because time is like a like recorded in history.
That's so fascinating.
Anyway, I don't know what to like.
No, it's fine. This is very.
So this is transferring things. Something. Delete this. Create a kitty. Anyway, this is a very elaborate NFT. We could try to find a simpler, like, what does a foundation NFT look like?
What does a foundation NFT mean?
Oh, this is a very popular
Here again, we may
site
be
for.
getting into unsafe content here. So
Okay, I won't scroll too much, but this is a website where you can buy and sell like art NFTs. But I suspect they have a sort of standard contract that they use. I'm just trying to find a simpler one because I bet there is. I don't know. I could have researched this before, but anyway, the point I'm trying to make is this is the interface, but there's a whole ton of stuff that you can implement behind this interface that is interesting or different or innovative.
crazy. Well,
I just got excited about this. Like it just seemed like a whole new universe of code with like a different kind of like properties to it, and like I think people are excited about it. They don't really know what to do with it. Like
it's missing its VisiCalc. It's found its VisiCalc, hasn't it?
Well, I think this like buying and selling artwork is sort of the VisiCalc of it, or at least the.
It's certainly risen into prominence, right? It's like people are aware of this now.
But it just seems so like the range of expression is so large that there must be many other interesting things in here that I haven't heard of before. Maybe nobody's even thought of before.
What interests me so much about this is, from what I've learned today, is the programming language aspect of it. I like the idea, just like storage is being accessed so differently, that money is a primitive, that time is a primitive. Like those things just don't. That's just not how the languages that I typically use. In part because I do UI frameworks, right? Like UI frameworks don't think about writing to tape, which is effectively what we're doing here, right?
But this has happened a few times, right? So like in previous generations of computing, the difference between memory and disk was really important. And you used to think really hard about like moving things from memory to disk, because disk could mean like scrolling your tape to like another part, right? But when you write a UI framework, you're mostly living in this random access computer world where you have many hundreds of megabytes of memory for you to slosh around in, and we have a ton of technology built up around that computing model. But this again is a different one.
It also makes me wonder, like, what we're missing out in the UI framework space with our language choices. I mean, our language choice, the one that I work on, is dominated by the need to compile the JavaScript. That's like this fundamental axiomatic decision of the language. Comes down all the way to like the integer types being like the JavaScript integer types, and like so we don't get to think about like, well, really we should have a screen buffer primitive, or some other. I don't even know if that's the right thing, and this opened my mind to that idea.
But you even exist in sort of a privileged position, because UI toolkits are one of the like main inciting use cases for object-oriented languages. Like when people were explaining what Smalltalk is all about, they did it in the context of a UI toolkit to use in the Smalltalk computer, in the same way that the like inciting, motivating application for C was writing Unix. But there are many other application domains that have like no relationship to the language that they use. They just take a general purpose language and smash it into their problem.
It also makes me think about the problem of language creation and like problem that, but I don't mean that like it's bad that languages are creating, but like that the question of like and how that happens. Like I think about the language diversity, and sometimes I sort of like bemoan it. But like, oh my, like yet another language, like why? But here is a clear example of like.
Well, they for the things they could use JavaScript, or the things they could use sort of like a normal language for, they clearly were like, okay, JavaScript is what we're doing. But like for this stuff, like it's not like, I don't think it's even close. Like I don't think any existing language could give you.
You just can't write this in Kotlin or Swift or.
Yeah, like the concerns that you're working with here are just so different from the concerns that people in other domains are working with.
And you need it to be, you need these things to be primitive so that you can control how it compiles down to this bytecode, right? You don't want to.
Correct, and I think they even haven't done enough. Like I think they like.
Oh, clearly.
I don't think they've accounted for the security aspect.
Yeah.
enough in the design of the application language.
Yeah, I think it'd be fascinating to throw this in front of, language people, or even just stare at it for a while and be like, how would you rewrite CryptoKitties to be, you like obviously secure?
Mm-hmm.
So, anyways, this was fascinating, Adam. Thank you for taking us on a tour of the blockchain.
I mean, I know very little about it. There's many people who are way more expert.
Oh, sure.
And but at least we got a little taste of it. Yeah.
Yeah. So, any final words for our viewers or updates on the pizza?
Well, we had eggplant parmesan tonight instead of pizza. It was very good. I enjoyed it quite a bit.
I remember when, before the pandemic and you and I used to get to spend in-person time together, we've made eggplant parmesan and chicken parmesan together, and it has been delicious. So
we battled the eggplant parmesan against the chicken parmesan. Vegetarians versus non-vegetarians.
I look forward to trying these battles again someday. So anyways, wonderful to see you. See you in a week.
Yeah, see you next week.